Good day everyone! In this video, we will discuss composition of functions. Composition of functions. Let f and g be functions. The composition denoted by f composition of g is defined by f composition of g of x is equal to f of g of x. Meaning, composition of function is substituting a function to the variable of another function. The second function is the function to be substituted to the first function. Let us take a look at this example. Given the functions f of x equals x minus 1 and g of x equals 2x plus 1, find f composition of g of x. Remember that f composition of g of x is equal to f of g of x. Notice here that we need to substitute to the x of f of x is the function g of x. So this x will become g of x. So what will happen is substitute 2x plus 1 to the x of f of x. So you will have 2x plus 1, then minus 1. Then simplify this equation. So you will have 2x plus 1 minus 1 will give you simply 2x. So therefore, f composition of g of x is equal to 2x. Let us have another example. Let f of x be equal to 2x minus 1 and g of x be equal to 2x plus 1. What we need to find this time is g composition of f of x. So from here, g composition of f of x is equal to g of f of x. This time, what we need to change is the x on the g of x, and we need to substitute f of x to this x. So this x will become the entire f of x. So what will happen is 2, copy 2, times x will be changed into x minus 1. So that would be 2 times x minus 1 and then plus 1. From here, you will notice that the x of the outer function g became the first function f of x, x minus 1. Then, simplify. 2 times x is 2x, then 2 times negative 1 is negative 2, then bring down plus 1. Simplifying this, we will have 2x minus 1. So therefore, g of f of x is equal to 2x minus 1. Now, let us consider this example. Given the functions f of x equals 2x squared plus 3x plus 1 and g of x equals 2x plus 1, find f of g of x. So remember that f of g of x is equal to f of g of x, meaning these x in f of x will be changed into g of x, which is 2x plus 1. So we will have 2 quantity. Remember that we need to change this x into 2x plus 1. So 2x plus 1 quantity squared, because we have it squared here, and then plus 3 quantity, again change this x into 2x plus 1. There you go, and then plus 1. In simplifying this expression, we need to simplify first this. 2x plus 1 quantity squared is equal to 2 quantity 4x squared plus 4x plus 1. Then plus 3 quantity 2x plus 1 and then plus 1. The next thing to do is to distribute 2 to this trinomial and 3 to this binomial. So we will have 2 times 4x squared is 8x squared plus positive 2 times positive 4x is positive 8x. Then positive 2 times positive 1 is positive 2. The same thing goes for positive 3. Distribute it rather to the binomial 2x plus 1. So we will have positive 6x. Positive 3 times positive 1 is positive 3 and then plus 1. Okay. So combine like terms, we can combine 8x and 6x. But since we don't have other terms with the variable x squared, so we simply copy it, 8x squared. So once again, combine positive 8x to positive 6x. So you will have positive 14x. Then combine positive 2 plus 3 plus 1. So that will be plus 6. So therefore, the final answer is 8x squared plus 14x plus 6. Okay, let me box it. There you go. For the last example, given the functions f of x equals 2x squared plus 3x plus 1 and g of x equals 2x plus 1, find g composition of f of x. So here, g composition of f of x is equal to g of f of x. So from here, notice that we need to change the x on the g of x by the f of x, which is 2x squared plus 3x plus 1. So this x will be changed into this function. So we will have 2 quantity or 2 times 2x squared plus 3x plus 1 and then copy plus 1 there. Okay. So distribute 2 to the trinomial inside, then you will have 4x squared plus 6x plus 2 and then plus 1. Okay. So from here, what we can combine is positive 2 and positive 1. So we simply bring down or copy 4x squared plus 6x and then plus 3. So therefore, the final answer of g composition of f of x is 4x squared plus 6x plus 3. So as we end this discussion, remember that the definition of composition of function is let f and g be functions. The composition denoted by f composition of g is defined by f composition of g of x is equal to f of g of x. And also remember that f composition of g of x is not always equal to g composition of f of x. F of g of x is different from g of f of x. I hope that you have understood the lesson for today, and for the next video, we will discuss the introduction to rational equations, functions, and inequalities. Thank you and see you on our next discussion.